And today we're going to discuss yet another really bizarre discovery coming from the edge of the universe. Something from the early universe that's challenging our fundamental understanding of how some of the largest structures in the cosmos are usually built. And specifically, a very strange galactic cluster that scientists never thought could possibly exist until it was officially discovered not so long ago. But some of the recent studies using observations from ALMA, observing this in the millimeter wavelengths, revealed additional details that make this particular cluster even more bizarre. Because here this baby galactic cluster seems to be far more mature and way more energetic than anything we've seen before, or anything that should be possible according to modern models. And so here we're going to discuss the Mega Merger Cluster SPT2349-59, a relatively massive collection of galaxies that existed 12.3 billion years ago and seems to be at a distance of just over 24 billion light years. Or essentially this existed about 1.4 billion years following the Big Bang, when the universe was only about 10% of its current age. And initially this was actually spotted by the so-called South Pole Telescope back in 2010, but it was just a tiny smudge and did not appear as anything important. And so basically here these initial observations made this look like any other cluster really far away. But the follow-up studies, several of which you can find in the description from the last few months, revealed something truly extreme. This seems to be a colossal pileup of at least 30 active galaxies, with at least 14 of these, as you see in this image, being really massive starburst galaxies, producing stars at least 5,000 to maybe 10,000 times faster than the Milky Way galaxy. But what makes this region even more bizarre is the size. All of this activity seems to be crammed into a region only about 3 times larger than the Milky Way, roughly around 500,000 light years across, which makes this a truly bizarre discovery. A discovery we never really imagined to find, because it kind of doesn't make sense. And well, right now, based on a lot of additional observations, scientists believe that this structure seems to be a progenitor of a lot of different massive galactic clusters that eventually merge into a single, ginormous elliptical galaxy. And so in some sense, what we're seeing here will eventually become possibly one of the largest galaxies in the universe. But the newest and the most shocking discovery from this cluster is actually in regards to its additional properties and especially the temperature of gas. Because here the gas between galaxies, usually referred to as ICM or intra-cluster medium, also does not make a lot of sense. It's just way too hot. And that's because according to most cosmological models, galaxy clusters are supposed to accumulate their gas relatively slowly, and that means that gas should also be heating up pretty slow, usually taking billions of years to be pulled toward galaxies, and eventually become hot enough that it becomes visible from really far away. But here in one of the recent studies from University of British Columbia, by using a very clever technique referred to as the Sunyaev-Zeldovich effect, scientists confirmed that the temperature of gas in this cluster is ridiculously hot. As a matter of fact, millions of degrees, which is completely unexpected. Although I guess a quick side note, in order to measure this temperature, scientists have to rely on the observations of the cosmic microwave background. And so essentially when some of the gas interacts with the cosmic microwave background, the photons that pass through this cluster receive a tiny energy boost from all of this hot gas, which then becomes visible in the CMB observations. And so in this particular case, the observations in the CMB revealed that this cluster is super hot, with the signals from this cluster being so strong that researchers were actually skeptical at first. But nevertheless, a few months back, they decided to publish their study because none of this really made sense. But importantly, by using additional observations and additional telescopes, they indeed confirmed that the temperature seems to be at least 10 million Kelvin, or at least 10 times hotter than predicted by most simulations and most cosmological models. In other words, this baby cluster seems to be blazing with heat and should not appear this way for at least a few billion years. And mostly because gravity alone should not actually create something like this, so this energy must be coming from somewhere else entirely. And this is where additional studies you can find in the description try to find the actual source. And at least one study discovers a lot of radio-loud AGNs, active galactic nuclei, or basically supermassive black holes that are extremely active and produce a lot of heat. This is of course black holes in centers of these galaxies. And so here, by feeding on a lot of gas and launching powerful jets, and also creating a lot of very powerful winds, some of these black holes seem to create so much heat that it then heats up the entire region, essentially making it glow from really far away, with the initial studies identifying one central black hole, but then eventually identifying 3 more extremely close to the center. And so at least 4 of these black holes seem to be launching a lot of mechanical energy through jets that have now been confirmed to be at least 22,000 light years in length, in essence making them act as a kind of a cosmic blowtorch that preheats the gas before the cluster has even finished forming. And so the energy coming from these black holes seems to be large enough to explain most of this overheated gas, but also additional signals visible inside of this really strange cluster. But beyond the heat and the black holes, astronomers also discovered evidence for an extremely chaotic, massy birth of all of the galaxies and stars in this region. And specifically by imaging ionized carbon emissions, they actually discovered a lot of giant gas streams that seem to stretch for 200,000 light years. And these are fragments of extremely turbulent gas that are not inside galaxies, but instead represent gas that was stripped from galaxies through tidal interactions, and are basically kind of like trails of gas extending from galaxies in all directions. In a nutshell, these are leftovers from massive collisions, and once again confirm that this is going to result in a kind of a mega merger. All of these objects are eventually going to merge into one single object. But because these gas trails show signs of being shock heated, this further contributes to the cluster's energetic environment, with additional observations by other telescopes revealing a lot of gas that is now stuck between galaxies, basically acting as a kind of a building block for the future megagalaxy and all of its stars, but also serving as food for a lot of those supermassive black holes in the center. But why exactly does any of this matter? Well, as I mentioned, this kind of, sort of, violates some of the modern models. And that's because currently most models suggest a kind of a hierarchical bottom-up sequence where things build up gradually and galaxies grow larger and larger and hotter at a much slower pace. Yet here the cluster SPT 2349-59 seems to suggest that the birth of these clusters, or at least some clusters, might have been super chaotic and very fast, and involved rapid evolution and rapid heating. And so if ancient clusters can reach these extreme temperatures and accumulate this much mass so quickly, we may need to rework some of the models and basically rethink how fast we think galaxies can form and how fast galactic clusters can develop as well. In more scientific terms, this currently challenges our understanding of baryon cycle, how fast the gas moves into and out of galaxies, and how black holes shape the environment of entire clusters right from the start. Or I guess just to make it a little bit more clear, basically imagine finding some kind of a toddler, but with the strength and the voice of a professional wrestler. Here I think most of us would immediately realize that our understanding of human growth is basically missing some crucial chapters. And this is effectively what this cluster is doing for our understanding of the universe itself. First, it suggests that gravitational processes alone cannot explain such ridiculously high temperature. As a matter of fact, its temperature is even higher than most modern clusters around us. And second, it also suggests that there's a lot of feedback and a lot of interaction with massive black holes in the center that seem to produce additional effects we never considered. And that means that some of the future models have to consider a lot of these extra factors when trying to simulate the universe and when trying to understand how galaxies and clusters evolve. And so what started as this tiny dot in this image from 2010 has now been interpreted as probably one of the most important galactic clusters discovered in the last few years. A cluster that confirms the universe is much more mysterious than we ever thought. But because this is such an unusual discovery, we'll definitely come back and discuss this more once there are some updates, or once researchers discover another bizarre cluster somewhere out there that pushes the boundaries of our understanding just a little bit more. And so until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access and a few more things. You can also support the channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.